Are you there?
I'm here. Morning. Thanks, Sean. Welcome to everybody. This is the second part of the session around the floor drains. We actually look at the drainage that is connected to that. Just to recap, we had a couple of cases over the holidays where things went horribly wrong, and all because it started wrong. So I'd just like to recap on what we said last week. When we look at floor drains, it is a fitting into which wastewater from a floor is discharged, and that is normally connected to discharge pipe. A branch discharge conveys such discharge to a gully, a stack, or an open channel. We are going to get back to that, or to this last bit, yeah. But if you remember, we looked at this diagram, and basically I said, because I had no feedback from anyone this week. So I said that when we look at floor drains, we look at fittings that are in this case, a commercial kitchen. So that would be like a hotel or a restaurant, where you do have floor drains having indirect waste dispensing into them, whether they have appliances dispensing into them. And for the guys that have been around the block for a bit, we do have, or you do remember, these kitchens actually get fitted with not bain-marie. You get these steamer units where the pots and pans and the dishes and that get steamed to get them sterilized or to get them cleaned up and the grease off them and what have you not. And you will find that in most of those cases where these designs have been done, or where there's allowance made for these fittings or these units, that the requirement would be for them to actually have the riser and the section, or the first 2 meters, or the section of the drain, or that waste going into the drain, for it to be of a metallic type. We can't have steam discharging into a normal UPVC pipe. It actually just collapses the whole thing. So yes, some of those indirect waste you might find is actually a galvanized pipe, or of a metal, like a Procast, or those cast iron pipes with the SNN couplings, to make sure that the water gets, or the steam in the water gets an opportunity to cool down slightly before it actually gets into the drain. So not particularly comfortable with the word sewer in there. Sewer belongs to the municipality, or it belongs to the local authority. But basically what you're looking at is, when it comes to the drainage, you have got the line discharging to the grease interceptor or the grease trap, and then you do have a normal stack that ends up going directly to the drain. But the grease traps we'll talk about next week, because there's a whole rigmarole around them. But in the meantime, for the ones that are going to the drain, and once the grease interceptor has done its work and it ends up in that drain, it also apportions to, just get this tool out, yeah? There we go. So the section that goes directly to the drain, or via the grease interceptor to the drain, this is the bit that we're going to be discussing today. When we look at SANS 10400 Part B, which is the bit that the building control officer needs to enforce, or the bit that when your job gets inspected at the end of the project, this is what is applicable. And we'll see in there that drains shall be installed in accordance with the requirements of SANS 1200 DB, LB, and LD. 1200 or SANS 1200, I can tell you, is one document that ends up, I've got it in my office here. It ends up filling 2 lever arch files. It is made up of loads and loads of little documents, starting from site prep right through to handing over site, reinstating the natural vegetation, anything to do with engineering or civils work and drainage and manuals and all the rest of that. So what 10400P has done is it's latched onto this document, and for the guys that attended the drainage presentations, when we're looking at trenches, bedding, and the actual pipe work, then all of these things, all of these standards as far as civils and the drainage work is concerned gets dragged back into 10400 Part P when you talk about drainage. So when we look at the application of 10400 Part, or the application of the National Building Regulations as far as Part P is concerned, the requirement is that where a portion of drain passes through a building, such portion shall be first of all supported throughout its entire length. In other words, you have it on a proper bed, it's backfilled, it's the way it should be, and then it be so placed that any junction, bend, or point of access into it is readily accessible. Readily accessible is might differ from one plumber to another or from one designer to another. The main thing is, as far as readily accessible, or the reference to readily accessible, is you don't have to knock down a wall or chop up a floor or break down half a building to get into a drain. Readily accessible should have bolted covers, should have like a manhole cover or a grid, or in a floor drains case, a basket with a lid over it. So readily accessible is that. We don't want to chop up buildings and damage things just to get to a point that is giving you grief. Then the next bit, as far as the generic reference to drainage is concerned, a drain shall be laid in a straight line between any points where changes of direction or gradients occur. In other words, you can't nilly-willy move from one fitting to another, or like in that first diagram, if you have 6 or 7 things connecting into it, you have a straight line between points where change of direction or gradients occur, and everything else connects into that line. Be laid with suitable flexible joints. That is stock standard for whether you use a loose collar or like a single socket with a rubber and a glue end, or you use pipes with integral or integrated sockets. They all have rubber joints, so you do have flexible joints to make allowance for any hot and cold and movement that might occur in the ground. And then be laid at a gradient, and I dropped out the middle bit, just gets to suitable for the load. This whole floor drain diagram starts off by saying that we're looking at waste, so there will be no soil connected to that drain. You're looking at a straightforward, all waste pipes, and if a proper grease trap is installed, you should have very little solids or very little, let's call them out of place material, or material that's out of place. It should be reasonably clean wastewater running through that, and it shouldn't be then a problem to actually get rid of that load going down that drain there, provided that all the other conditions have been met. And then while we're looking at the drainage ones, then very important, remember that diagram shows a number of changes of direction and connections under the floor. And then it specifically, the standard requires that where any drain has a branch drain connected to it, such a connection shall be by means of a junction, which shall not be a saddle. Take note, we looked at previously on these tech talks, we looked at those strap-on saddles. The requirement is that if you do a connection into a drain with a branch, it'll be a junction fitting, not a saddle. So the second point says, enable the flow from the branch drain to enter the drain obliquely, axis of the drains not to exceed 45 degrees. So that's a stock, that's a fitting that you buy. That is, whether it be an IE or whether it be a plain junction, you're looking at 45 degrees, and anything joining at that 45 degrees or with that 45 degrees back into the drain would get swept into the line without causing obstruction. The moment you turn this thing square, you'll have water coming in here, and it would actually hit the other side of the junction, and it would cause an obstruction in that main flow that ends up going through that junction. So the requirement is 45 degrees maximum. You cannot exceed 45. So you can't start adding a little, if it's a stack outside, it's no problem. You add a 45-degree bend, you square it off, you work on that. But when it is in that building or under that floor, you keep them at 45. We keep them flowing with the natural or the intended gradient, or with the flow that was originally designed. When we look at these floor drains, it is very important to understand that the national building regulations and 10400 part P says that the floors supposed to drain into these traps start at a minimum of 1 in 200. For the guys that do civils work or stormwater, 1 in 200 is almost level. So yes, there is movement, but the water would never enter that floor drain or that trap at a rate of knots. So you'll find that most of these units are designed that your floor would be running at 1 in 200, but you would end up with a sizable drop so that when the water starts hitting the trap, it would actually go through the trap and it would pick up speed going down here and then into the pipe being flowed. So if you look at the previous slide, if there's a decent gradient on it, or there's enough, what would you call it, velocity created in that fitting, and with that drop there, the only other thing a plumber could do to actually make sure that you don't end up getting hassles is by using 245 degrees or a long radius bend as allowed by 10400 part P and 0252 part 2. And you're looking at no sharp or no restrictions. The drain laid at a decent gradient. You've got 2 of these 45 degrees bends at the bottom, which means that if you need to open the slot up and you need to access that drain and rod through towards the connection point or towards that drain going out, you'll be able to go through those long radius bends at the bottom. So now you've started at very little, the water's trickled in here, it drops into the floor trap, and you create that long radius to get this thing flowing into the direction through the junction to the outside. So if that was to be a 90 bend, you'd end up finding that it'll probably just bounce along into that bend and it'll slow down. And the next lot comes in there, and every little bit of dirt or any fat or anything that happens to slip through the strainer inside would then start building up here, and short before long you'd have to clean it, but with no readily accessible, or not being readily accessible because of that knuckle bend or that 90-degree bend at the bottom, you wouldn't be able to clean that. So the only way the plumber can get this thing to go in his favor is by using long radius, making sure that everything remains accessible. And like I said, you get a decent enough drop to get it going. We get to the next sheet, and it'll tell you that the minimum design velocity of a flow needed to obtain self-cleansing. That's what a drain does. When you flush it, it cleans itself. Only when there's foreign material or there's obstruction or there's an issue somewhere along the line, you would need to assist or clean up. So at 0.6 meters per second, whatever you put down there, that line should clean itself until doomsday. The only time you end up having hassles is if you have fat buildup, you have solids that have gone, or in some cases, I don't know how many of the guys do maintenance. You'll find that a lot of the guys, especially in the bigger kitchens, and I don't know why it happens in the huge or the more complex setups, they end up taking that basket out, because instead of cleaning it every day or every second day and taking out the solids, it's easier to take the basket out. So you'll find that guys end up cleaning plates into these things, and whatever's on the floor gets kicked into this floor drain. And those things aside, that drain will look after itself forever. Then you'll find that the design depth of flow, let's call it, if we want to simplify that, let's call it 2/3 times the diameter. That is the around where the diameter of the pipe being under the floor. The flow from those fittings would not be, or would not preferably be, more than 2/3 of the pipe, with a maximum depth of 3/4 times of the diameter, because you need air in that pipe. You need the air in the top to keep it flowing. If you start filling a 110 pipe up 100, like at full capacity to 100%, you'll find that it'll hardly move properly because it's got no air to get the thing going. Then if we look at the branches, like I indicated with those junctions, the branches should be designed about half the diameter of that pipe coming in there. So you can't have a branch coming into a drain where you end up with the main drain having one fitting on it, and then on that junction or on that branch picking up the floor drain or the stack inside that kitchen. That thing's got 20 connections into it, so you end up having more water coming from the branches and then obstructing the main run. If you look at these things here, this you'll notice all comes or should be considered early on in the game or early on in the process. And then we look at where these guys, when you go do maintenance, I'm thinking, would it be possible for Sean? Would it be possible for the guys to, like a show of hands, the guys that do maintenance, just for my interest sake and for possibly adding on to this information, the guys that do maintenance or that have had hassles with existing floor drains in butchers or delis or shopping centers or whatever, if they just a show of hands here, please. I'll
So
carry on.
Ahead on your face, guys, just go ahead and just click the hands up button, and then I'll take them down at the end.
Thanks, Mia. And then in the meantime, we can carry on. So we've had a look at the branches, and then if you forget everything else I've said up to now, this is the only bit you need to take away from this tech talk. And if you see non-compliance to this, you know you're heading into the wrong direction. When you look at 10252, you'll find that it says any drainage installation, take note, any installation shall be provided with an overflow device or a gully to provide overflow relief in the event of sewage discharge. This is what happened during the holidays. Then it wasn't provided, or it was provided incorrectly, and it ended up being a huge hassle because the building got flooded. So the standard then continues to say that the overflow or flood level of such a overflow device or gully shall be at least 100 millimeters below, and I've omitted A because it's not applicable, the overflow level of any floor drain. Not the ones that you see, not the one closest to the gully. The overflow level should be 100 millimeters below the overflow level of any floor drain. So obviously we're looking at design stage, or we're looking at initial stages, but if you do find that there's continuous blockage or continuous spillage going on in a specific building, it might be in your best interest to do this little sketch to try and clarify that. This, or the previous slide says the overflow device, which in this case would be a gully, and if the gully complies with 10400 and 10252, it would have a rise not less than 150, so that nothing can actually run into that area as far as stormwater and that's concerned. And then you look at the floor level, where your floor drains, albeit tiled area or epoxy or whatever finishes could possibly be on there, that floor level, or the difference between that floor drain level and the overflow or flood level outside, we're looking at a minimum of 100. We've had some very nice designs where, especially if there's a bit of slope on the ground or there's a parking area, if you could get that floor drain to discharge into a drain and end up being or falling over the gully instead of into the drain with a gully, that's first prize. Even if you have to shorten the run and put out 1 or 2 lines instead of having a one long run, and you end up going over the gully, it makes life even easier. But if you do have this minimum of 100, that means if this drain blocks, or it's the charges, or the municipal sewer connection is blocked, or something happens that shouldn't, then at least it would overflow at gully level outside onto natural ground level long before it starts causing damage inside. So what we can do is we look at these are actual cases where these floor drains start charging because you've left an opening, or there is an opening from the drainage system going into that kitchen, and you'll find that everything starts floating. And if you're really bad luck, you'll find that the kitchen and the actual eating area in the restaurant, or the mess, or the wherever you go, is on the same level, and the water starts pouring out of the kitchen into the restaurant. I'll tell you something, you'll probably find that place vacated in a jiffy. So just to hop onto that same, if you can't comply with that, the requirements of the standard to actually keep the flood level below the level of the kitchen, in some cases you'll find that some of the landlords or some of the designers will even insist on a proper air break, not even into the drain or into the gully. It would be an air break between the actual drain and the level or of that floor drain. I just wonder, while we're looking at this, before I continue, if we go back to this slide, that floor drain conveys discharge to a gully, a stack, or an open channel. You'll note that that floor drain, according to its definition or the definition of a floor drain, does not discharge directly into a drain. It says over a gully into a stack, which means there's already a drop between where the pipe comes out the building and the invert level of the drain if you put up a stack there, or an open channel on the outside which gives you the air gap that you require. So at no stage does it tell you that you can connect it directly to the drain. So if you look at these cases here, when you do this maintenance, or when you do talk to a client, you're looking at, if this had to happen in a kitchen serving a restaurant or your favorite takeaway shop or a shopping center where what are they normally, they're called food courts. So you'll have food court, most of them will be connected to the same drain, and you end up getting fat into those lines and the things are charges. You're looking at, if the owner is not of a moral character or of a what would you call it, a character, to decide and close this thing on its own while he sorts this out. I can tell you something, your local authority, health department, or any such department would do that in a jiffy. They'll walk in and they'll say, chaps, this thing is not safe, contaminated here. So you're looking at downtime for cleaning it up, disinfecting it, the odor. I mean, we've all cleaned up gullies that have had kitchen waste into them. It is a huge pong. So if you add normal, or you add the soil to the waste, you end up with a kitchen that smells like something you shouldn't be in, and then you still end up having to remove the odors and that. And then everything that was in the kitchen, albeit a pocket of potatoes that was standing on the ground or anything that was left in there. I don't know, you've seen the inside of these big kitchens. We've all seen MasterChef, when they start running around, they drop stuff, they put stuff down. When all of that will have to be discarded, so that's a dead loss. And then most of the time, poor plumber comes there after the effect, job was done. Now the owner wants to know, okay, how can we avoid this happening again? So then either the landlord or the owner of the building then has to start investing money because the floor drain wasn't done properly. When we look at cold rooms, and it's funny to mention this in the same thing, we might be looking at freezer rooms for meat or any such type of freezing of product. And if you Google it and you'll look at the available options, you'll see it actually includes the cold room in a mortuary. You cannot have a drain point inside there because of the very reason of flooding, because of opening up points for cockroaches and all kinds of weird animals to get into your freezer. So you'll find that the ones that are installed afterwards have got cooling elements in the floor, so there's a step to avoid water just flooding into that area where the food or whatever is in there. And you'll find those ones have all got channels the width of the door, so that when you do need to flush or clean out or wash down that floor, it ends up coming out of that area and over this heavy duty stainless steel floor drain that will then get rid of the water that was in there. So if you do get asked to look at something like this, just bear in mind, when you're dealing with the food or anything like these freezers or cold rooms or whatever, there are no drains in those things, or there's no direct drain in that. You can go back to the door, you could have that whole thing will get washed into that drain, everybody's happy. Then our dear friends from the air conditioning industry, they see a pipe, whether it be a waste pipe, whether it be a single stack, whether it be a two-pipe system, whatever, if there's anything in there, they drill a hole and a 25 mil discharge just disappears. And it ends up going into an area where if that aircon is not used and there's no condensate, first thing that happens is that self-made trap dries out, and the smell from that drainage run or line or stack then comes all the way back, and it ends up venting into the unit. This one, a couple of things, not 100% kosher here, but at least this one is outside and it is open. The only problem is, like I said, you don't use these things, then that trap becomes a hassle because it dries out and the smell starts outside and it ends up wafting through into the air cons. This one's not even trapped, it's just drilled into the waste pipe. This little detail I took from a air conditioning pamphlet, and you'll see that when it comes to the manufacture of those aircon units or the actual industry, there is a requirement for an air gap. First of all, not straight in, not just drilled into a stack, an air gap and a self-sealing device. I don't know what the aircon guys use as a self-sealing device. A tundish and an air gap. That is pretty much what the discharge from an aircon should look like, not like these examples up here. So you'll find that. In conclusion, I'd just like to say that anything that is not drainage or waste related probably doesn't belong in there, and special provisions need to be made for that. So as far as floor drains, condensates, freezer rooms, all of those types of things are concerned, that's my little bit. And my last thing I need to know is, are there any questions?
We do have a couple of questions, but just before I do get into that, your hands raised was 25% of the audience.
Okay, so do we have it happening? So thank you. And now
All
the
right,
questions.
perfect. On to the questions. The first one reads, or in your presentation, it looks like there's a 50mm connection under the floor. Are we allowed that?
Yes, that is if you look at the standard, it says that you can connect a waste pipe or that indirect waste pipe, as long as that 50mm is in the same room where that connection is made. If it's a drain or something that needs to run into a drain, you can't have that 50mm diameter because it's not 110. But in that floor drain, you've got access from that floor drain and from the actual sanitary fixture that you're draining. So for that waste pipe, it is acceptable, but waste pipes in slabs and disappearing without access, that is something altogether different. The standard only refers to the waste from that room.
All right, the next one reads, what about a grease trap? Must it lead to a gully first and then to a grease trap?
Not necessarily. I can tell you that next week's 20 minutes or half an hour that we're going to be doing Tech Talk will be around grease traps only from start to finish. So thanks for the leading up to next week. But no, you don't have to go over a gully first. You can have it going into a stack. If that thing is functioning properly, then it shouldn't be a problem. But next week we'll look at that in detail.
All right, perfect. The last question we've got here is, hi, I just wanted to make sure that on a 3-story building, my client wanted to make a hole in the floor for his toilet drain, but I advised it is not possible as it weakens the floor. His second option was going through the wall, but all pipe work is cast iron and the main sub stack. Is there a way to tie into existing cast iron pipes that has no brass break off points?
As far as I know, yes, depending on the type of cast iron you're referring to. I do recall having worked on some of those units before. They're called S and N couplings. It is a stainless steel outer with a rubber inner, and you end up, the rubber you can flop over like a normal Kimberley socket. You can flop that onto the new. If it's a pro casting, it'll probably go straight on. If it's a PVC that you need to add in or to cut in somewhere, the rubber would be the inner, like the flange, and the stainless steel with those 2 huge stainless steel clamps on the outside. You can use that. Because yeah, like you say, there's no repair coupling for cast iron, but you can make do with the fittings or the connectors that are available. If it doesn't answer the question, he's got my, or they've got my email address. You can just send me a thing. I'll pop it through to you.
All right, perfect. Just the follow-up question to that one is, where do you, or who supplies those couplings?
Yeah. Could be a number of suppliers. Like I said, pop me an email and we'll sort it. I know the not the civil guy, the guys that are. I'm sure if you contact your local plumbing shop and you ask for it, it is, I know it's definitely available because they still use Procast. I say Procast, those red thin skin cast iron pipes, they're being used all over still for hospitals and areas where there's vandalism or there's excessively hot water and all kinds of things that crop up. So they are still available. There might be something else that I'm not thinking of at the moment, but if we can find out, that's not a problem.
All right, perfect. Just a follow-up comment on that is SSN couplings are available freely. That's from Richard Bailey in the audience.
Richard, you star, bro.
There we go. The next question is, are aircon discharge allowed into the sewer?
The actual discharge, yes. I mean, that's water, it's condensate, it's hot and cold mixing, so you get water being formed or condensate being formed. It's the way that it enters the thing that's a problem. Like that little, wait, I can do this. Kids are teaching me all kinds of funny things. There we go. You'll notice on the screen there now that air gap and the actual self-sealing device, you could get that into a fitting or you could get that into a stack if it's done properly, as long as there's an air gap and there's no chance of sewer gas or the smelly gas from the drainage going back into the building. And like I said, if there's a possibility of this little trap drying out because someone's not using it, you can see there's a problem. But for the actual condensate itself, it's not an hassle being in the drainage system.
All right, perfect. That is all of the questions I have got for you, but I do have a couple of questions about the email address, guys. I have sent it through the chat. I'll go ahead and send it again, but you can just pop him an email through that email. Other than that, guys, or Adrian, we do not have any more questions. Would you like to end off the session?
Yes, I can do that. Now, guys, I've already let the cat out of the bag. Next week, we're looking at grease traps and the applications and the requirements for them. And then we'll be done with the drainage bit for a little. I think Richard is up after me. So in the meantime, get out there, be safe, and get the things done the way they should be done.